All right, we're going to talk about the Pythagorean theorem. The Pythagorean theorem is used with right triangles, and a right triangle is simply a triangle with one right angle. Every triangle has two acute angles, but if it has one right angle, that makes it a right triangle. When the lengths of two sides of a right triangle are known, the length of the third side can be found using the Pythagorean theorem. There are a few exceptions to this. Let's say you only know one side. You're actually missing two sides. As long as they are the same variable, as long as those two missing sides are the same length, you could still find it. But typically we have the lengths of two sides, and we use Pythagorean theorem to find the length of the third side. So the Pythagorean theorem that says the square of the hypotenuse is equal to the sum of the squares of the legs. Well, in a right triangle, the two sides that create that right angle, those are both called legs. So each one of these sides is a leg. The side that's not a part of the right angle, the side that's opposite the right angle, is called the hypotenuse. Well, the Pythagorean theorem says the square of the hypotenuse is equal to the sum of the squares of the legs. Now, we don't typically write it this way. We usually write it using variables. And when we do that, we typically use A, B, and C. A represents a leg, B represents a leg, and C represents the hypotenuse. So if I rewrite this with the variables, it would look like this. So this is the Pythagorean theorem. Alright, so let's try to use the Pythagorean theorem on example 1. It says find the value of x and round to the nearest tenth if necessary. We're just going to plug them into the Pythagorean theorem. Now, you notice it is a right triangle, and we are dealing with the sides. You've been given two sides and you're finding the third. So this is the perfect time to use the Pythagorean theorem. When you use the Pythagorean theorem, you need to identify the hypotenuse, the side opposite the right angle, and make sure that that is C. Now, you have two legs, one of them is A and one of them is B. It does not matter which one is A and which one is B. Those are completely interchangeable. The important part is to make sure that you're using the hypotenuse for C. So A could be 3, B could be 7. And once we've substituted everything in, we have an equation with only one variable. We can solve this equation. So 3 squared is 9. 7 squared is 49. We add those together. And then for the last step, we got to get rid of that squared. So we do the opposite operation and we take the square root. And it says round to the nearest tenth if necessary. So you would plug this in the calculator. And when you round to the nearest tenth, you should get approximately 7.6. Alright, let's try this again. Let's try this again on example 2. Find the value of x and round to the nearest tenth if necessary. We have a right triangle. We've been given two sides. We're trying to find the third side. So we're using the Pythagorean theorem. Which side is the hypotenuse? Here's the right angle. The side opposite the right angle is the 6 square root of 2. So make sure that 6 square root of 2 goes in for C. That's the hypotenuse. Now, the A and the B does not matter which one's which. So you could do x squared plus 6 squared, or you could flip that around and do 6 squared plus x squared. It does not matter. Okay, now when you're squaring this, notice I put the parentheses around it because that's the way you'll need to enter it into the calculator if that's the way you square it. Because we want to make sure that all of 6 squared root of 2 gets squared and not just the last part of it. So 6 squared root of 2 squared should give you 72. 6 squared is 36. And we're just solving this equation for x. We want to get x all by itself. So get rid of the 36. And then the last step is always getting rid of that squared. So we're going to take the square root. And the square root of 36 is 6. All right, let's try another one. Alright, example 3. Find the value of x and round to the nearest tenth if necessary. Now, at first glance, this doesn't look like a Pythagorean theorem problem because I don't see a right triangle. However, if I were to draw a line in right here, I now have a right triangle over here. Since this is 8, this is going to be 8 because what we have right here is a rectangle, and so opposite sides are congruent. And then if this is 5, this is 5. Opposite sides of a rectangle are congruent. So if the length of this entire thing down here is 11, this piece is 5, we can just subtract that from 11 to find out what this is over here. So now we have a right triangle right here. I'm just going to focus on this right triangle. I know 2 of the sides. I can find that third side using Pythagorean theorem. So once I decide I'm using Pythagorean theorem, I identify the hypotenuse and make sure that we use that for C. So the hypotenuse here, opposite the right angle, is x. I make sure I put x in for C. And then the 8 and 6 can be A and B. Does not matter which one's which. So 8 squared is 64. 6 squared is 36. We add those together. And the last step, got to get rid of the squared, so we do the opposite operation and we take the square root. Alright, let's look at example 4. Find the value of x and round to the nearest tenth if necessary. Okay, we have a square. Notice all the sides are congruent and we got right angles. So this is a square. But when you draw this diagonal through the square, it splits that square into a couple of right triangles. So I'm going to be focusing just on a right triangle here. Okay? Well, in a square, all 4 of these angles are right angles. Okay, so if I'm focusing on either one of these triangles, they should be the same. Because if this is x, this is x, this is x, this is x, all those sides are congruent. Now this is one of those special cases I mentioned earlier. In this right triangle here, I have only been given one side. I'm actually missing 2 sides. But because those 2 sides are the same, they're congruent, I can still set up an equation using Pythagorean theorem and only have one variable. Okay? So again, the important part when you're plugging into Pythagorean theorem is to make sure you identify the hypotenuse correctly and put that in for C. So here's your right angle. Opposite the right angle is the 5 square root of 2. So make sure that goes in for C. And then the legs are both x. So A and B are both x. Okay, so first 5 square root of 2 squared is 50. And over here, we can combine like terms. X squared and x squared, same variables and exponents. Those are like terms. So we have one of them. We add another one. We now have 2 x squareds. And then we just continue the process of solving for x. So it's being multiplied by 2, so we divide by 2 to get rid of that 2. And then I want to get rid of the squared. So I got to do the opposite operation and take the square root. X is 5. Alright, one more example. It says find the length of a diagonal of a rectangle with length 8 and width 4 and round to the nearest tenth if necessary. So the first thing I would suggest doing is draw yourself a picture. So it says we're talking about a rectangle. So if you understand what a rectangle is, okay, there's a rectangle, and these should be right angles all the way around. All 4 angles are right angles. It says the length, find the length of a diagonal of a rectangle. Well, a diagonal goes from one vertex to another vertex through the center of the figure, so it's not one of the edges, not one of the sides. Okay, so when I put that in there, notice that that rectangle is split into right triangles. It's got a length of 8 and a width of 4. And we are finding the length of the diagonal. So I don't know what it is. I'm trying to find out what it is. So that's where we put our variable. So here's a rectangle, length of 8, width of 4, and we're trying to find out what the length of the diagonal is. So here we got a right triangle. Identify the hypotenuse and make sure we put that in for C. X is the hypotenuse because it's opposite the right angle. So the 4 and 8 are A and B. Does not matter which one's which. So 4 squared is 16. 8 squared is 64. Add those together. And then the last step, got to get rid of that squared, so we do the opposite operation. Take the square root. And if we type that in the calculator, you're going to get approximately 8.9 because it said to round to the nearest tenth, so we're keeping one number after the decimal point.